Welcome to my video on how to use weighted moving average on a simple data set. So weighted moving average is a simple technique for filling a gap. It is best used when the gap is small and there is a progression in the data. So in this case we have a 5-hole gap. We have values 16, 23, 28, 30, 5 NAs, 38, 40, 45, 53. So we have sort of a progression. We're having a positive progression in this case. This is stock market data. And then we have, so with weighted moving averages, we have two things we have to look at, K and weighting. So weighting is simple. So there's two types of weighting, exponential weighting and simple weighting. For the purpose of this video, you don't need to worry about exponential weighting. Exponential weighting is where it weighs points nearest to the data more than points away from the data. The one problem with this is if you have a data set where you have, in this case, 5 in a row missing, the points that the weighting will have massively adverse effects on your distribution. So don't use exponential weighting for now, because it has really adverse effects on how much your data will change. So now that we've used simple weighting, we can look at K. K is a simple value. What it will do is it will take a point. In this case, we're going to look at 0.5 here, circled in orange. And what it's going to do is going to go K units to the left, K points to the left, and K points to the right. In this toy example, K was 2. And go, do I have at least 2 data points? If yes, take the average, and that's our new data point. So, as an example here, K is 2. We have K units to the left, we have 2 data points. We went K units to the right, we have 0 data points. Okay, K was 2, we have 2 data points. We're done. So therefore, we impute the average of these 2 points, and that's our new missing data point. In this case, it would be the average between those 2. So then, the other thing is what happens when we don't get 2 data points. So let's say we're here at 6, we went 2 units out and 2 units out, and one may notice that we didn't get 2 data points. We got 1. What do we do here? Well, the way weighted moving averages work is they'll increase this window size, in this case by 1 each, 1 on the left and 1 on the right. So we got a new data point. So we have our 2, and now we impute the average of both, and that's our new data point. So there was 2 data points here and 2 data points here. A careful observer may notice that both of our data points, that we're going to get the same value for 5 and 6. This is not an accident. So I would like you to pause the video right now and tell me, if I chose K of 1 on our data set with 5 missing values, what would our data set look like? Alright, so the answer is we're going to get a point that looks like this. We're going to get the average between these 2 points, and we're going to get a horizontal line, in this case of only 2 points because we have a horizontal line. A point that is the average of this point and this point because it is in the center, and then another horizontal line that is these 2 points. There's the average of those 2, so it's going to look like this. Alright, sort of horizontal line, and if NA was bigger and bigger, it would increase. So now I also want you to pause the video right now and tell me what would happen if I chose a K of 8. Sorry, a K of 20. So what would happen if I chose K of 20? Alright, now that you know the K of 20 result, we look at all the results over here. We take all the results over here. Oh look, that's our entire data set. And we go, okay, impute the average of our entire data set, so that's the mean, which is here. And at this point, we impute the mean, which is here. So we get a horizontal line, and that's the mean. So if we chose a K of 1, we would get 2 horizontal lines, a point in the center, and a point in the center, if we had an odd number of missing data points. And then when we chose k of a large number, we would get a horizontal line of the mean. We can show this here in this R script. I'm going to run the data on our two values of k. So this is plot this data set. This was k of 1. As you can tell, we have 2 points here in the center, which are 0 each. We have our center data point, and we have our horizontal line over here. Now we have, this is called k infinity. So we have a horizontal line that represents our full data set. And then with k as 4, what would happen? So k is 4 in this case is sort of our more central case. We get a nice average and something that looks kind of more like a real data set. We have the issue that it kind of drops for no reason and then rises and then drops again. This is an artifact of the way this works, whereby in this case it was taking all the points to the left and going, okay, nothing to the right, we'll take the average of that and drop. And over here it was taking all the points to the right, and then none of the points to the left, take the average of that and drop. So it was going up and down, and because of one of the ways of weighting moving average, it would go up and down. Alright, actually, thank you very much for watching my video. I hope I informed you on how weighted moving averages work. If you have any questions or comments, please write them below in the comments. I'll try to respond to you immediately.